Now you can see that when the block is displaced to the right of the equilibrium, like this position, the force exerted by the spring acts to the left. So this is the force from the spring act to the object, and it point toward to the equilibrium point. Here it point to the left. And at this position, when the block is displaced to the left of the equilibrium, the force exerted by the spring act to the right. So when the object here is here, the force from the spring point toward to the equilibrium too, and now the direction is point to the right. So we can see that the force on the object will always point to the equilibrium point. It means that the force from the spring will always push or pull the object back to the equilibrium point. Such a system will oscillate back and forth if the object is disturbed from its equilibrium position, and it will exhibit the oscillatory motion. In the previous slide, we represent the system of the mass spring moving on the horizontal surface. However, we can use that qualitative description of the motion for the system that hang vertically. That is, if we have a block hanging from a vertical spring, all the results for the horizontal spring are the same for the vertical spring, except that when the block is placed on the vertical spring, its weight causes the spring to extend. If the resting position of the block is defined as the equilibrium position, or is a position that x is equal to 0, you may use y, that is not matter. The results of this chapter also apply to the vertical system. It means that if you have a spring hang vertically, if you have a spring hang vertically like this, and if there is no object hang with the spring, the equilibrium position of the spring, be careful, the equilibrium position of the spring is a position that there is no force. It means that if you do not pull or push the spring, so the position that the force from the spring is 0 is because you do nothing to the spring, and this position is the equilibrium position of the spring. I say that it is the equilibrium position for the spring. The equilibrium for the spring. Okay. The equilibrium position for the spring is the same for the spring hang vertically or placed on the horizontal plane. If we assume that this is the ideal spring, that is, that the spring has very small mass. However, when you hang an object with the vertical spring. The mass of the object will stretch the spring. Now the equilibrium position for the system. Be careful. This is the equilibrium position for the system. Is a position where the force from the spring Fs is cancelled by the gravitational force or the weight of the spring mg. So here the net force is 0, and we call this position x equal to 0 as the equilibrium of the system. And once you define the equilibrium of the system here at this point, after that you can use the result of the simple harmonic for the system of mass spring on the horizontal plane, for the system of the mass spring hang vertically.